Okay, so today's session is going to start and delivered by the Dr. K Dalla, and the topic will be the robotic motion visualization in manufacturing application using artificial intelligence. So let me introduce the today's resource person, Dr. K Dalla, and he is presently working as an assistant professor in the Department of Mechanical Engineering at National Institute of Technology, NIT Jamshedpur. Sir has completed his PhD in robotics from the IIT Roorkee and MTech from the IIT Bombay. Sir has a wide range of experience in the field of robotics and artificial intelligence. Sir has joined the NIT Jamshedpur from 2018. Before that, he has worked in different engineering colleges and industries also. Sir has completed his BTech from the Mechanical Engineering, Government Engineering College, Bilaspur, Chhattisgarh in 2006. Sir has 7 years of learning exposure in 2 IITs and 12 years of teaching and learning exposures in various institutes. Sir has the teaching interest in the field of robotics, automation, kinematics, dynamics, and control of mechanical systems, AI in robotics, machine learning in mechanical engineering, and smart materials. His research areas are space robotics, robotic dynamics, and control. Other than his robotic learning, he has also practical exposure to fracture mechanics, material science, and ceramic powder processing. He has published more than 30 research papers in the reputed journals all over the world. Sir has also attended several conference proceedings. Sir has written more than 3 book chapters, and he has also supervising PhD scholars in the NIT Jamshedpur. Sir has also supervised many MTech scholars in NIT Jamshedpur. Sir has received various fellowship from the MHRD, and he was associated with the 2BRNS project during the senior research fellowship in the IIT Bombay after his MTech in material science from IIT Bombay in 2008. Sir has also worked in several projects. He has 2 ongoing funded robotics projects from the Tihan, IIT Hyderabad, and IIT Guwahati. Technology Innovation and Development Foundation of IIT Guwahati. Sir has guided several students, and many students of Sir are participated in various competitions of the IITs, NITs, ISRO, DRDO, Robocon, RoboFest, etc. Sir has taken initiatives to develop robotics and embodied artificial intelligence laboratory at departmental level in NIT Jamshedpur at 2024. Sir has created robotics and automation club named RoboArt at institute level in 2024 at National Institute of Technology Jamshedpur. So Sir has delivered in various sessions more than 25 plus sessions in different FDPs, workshops, in different engineering colleges and institutes, where Sir has guided more than 15,000 participants. Sir has also reviewed several research papers and inspired various research scholars in the field of robotics. Skill development program. Sir has also conducted various skill development programs on the field of robotics and automation. Faculty development programs and workshops. Sir has conducted more than 6 ATAL FDPs and workshops motivational speaker and poetry writer. Sir has also various uh, uh, sessions delivered as a motivational speaker, appeared on the various news channels also. So sir has a wide range of experience in the field. So I believe that today's session will be very learning session, inspiring session for all of us and all the participants. You are requested to please listen properly because the assignments will be given to you, and for the certification, the completed assignment is the essential part. So therefore, uh, I request Dr. Vijay Kumar Dalla sir to please proceed the session, and the session is hand over to you, sir. Thank you for your time and accepting our request for this FDP program. So I welcome you, sir. I welcome all the participants. So that's all from my side. Thank you, sir.
Thank you, Dr. Hulas Tonde, for giving me this opportunity and briefing about me nicely. And obviously, thank you. I'm very much thankful to your institute, your college, Shreyans College of Engineering and Technology, Sambhaji Nagar, for taking this initiative and conducting FDP, Atal FDP on uh, a faculty development program on robotics and AI related topic. Am I audible, sir? My screen is visible?
Yes, sir. Your screen is visible. Yes.
Okay. Uh, so once again, I'm very much thankful uh, to get a chance to interact with the participants, dear participants, myself, Dr. Vijay Kumar Dalla, Assistant Professor, Grade 1 in the Department of Mechanical Engineering, NIT Jamshedpur, and I'm working here since May 2018. I have exposure in both during AmTech in material science and during my PhD in robotics. So I did my PhD in space robotics, and I'm currently working in the field of robotics, and a little bit I use AI, and my students they use machine learning. So a little bit there is changes in the topic. The topic is robotic motion visualization and use of AI in robotics. So, firstly, before that, talking on robotics, we should know about some basics, which are very much important, and then we can implement AI in the robotics, machine learning, and AI in robotics. So one can search before that because this kind of FDP, the purpose of FDP is to interact with the participants, faculty members, and students so that we can work collaboratively. If required in research, if required some guidance from here, my side, or you may be required for me. So that is the main motto. So you can search my name uh, in a LinkedIn profile. If you search me as Vijay Kumar Dalla, you will find me. So this is my profile, LinkedIn profile, and you can get my introduction. Also, in Google, suppose you type my name, so here you can find me. so that if required, we can interact in near future. Okay, so this is my profile. Regarding thesis supervision, so one PhD, one student is awarded, and another student who is Sarfraz Ahmad. He had submitted thesis, and now he has to defend his thesis. Okay, so now coming to the topic. So robotic motion visualization and use of AI in robotics. So robotic motion visualization in which what we will have exposure. We will have exposure of kinematics, dynamics of a robot, and uh, before that we should know what is a robot and what is the difference between robotics and automation. So you might be knowing automation. Let me uh, one question from my side, and let me make it more interactive. So you can reply your answer in the message box if it is allowed. So I'm asking just the difference between the robotics and the automation, or you can say robotics is a part of automation, or automation is a part of robotics. So you can reply in the message box if you are allowed.
Sir,
Huh.
robotics is the part of automation.
Yeah,
Automation is not a part of robotics.
yeah, right, sir. Right. Okay. And you might be knowing that types of automation. So robotics comes under the automation, and there are three types of automation. And the first one, fixed automation. The second one, flexible automation, and third one, programmable automation. So robotics comes under the flexible automation. Uh, okay. And what is the difference between the programmable automation and the flexible automation? So flexible automation, there will be no queue time for the machine setup for having different kind of products. But in the case of programmable automation, there will be suppose we produce one set of product, then need to change the machine uh, arrangement, means need to wait, then again the next production will be done. So that is avoided in the case of flexible automation. So यहाँ पे ये clear हो गया, the difference means what is the similarity, or you can say the robotics versus automation. Okay. And suppose if I ask, what is the difference between the simple automatic machine and a robot? If anyone can answer, it will be much better before. What is a robot? Robot क्या है?
Definitely, sir. Just a simple automation is like a bottling plant. An example, we are taking bottling plant. We are
Hmm.
refilling of the water, and it can be done by automated. No manual
Hmm.
process is there. But
Hmm.
in case of robotics, where
Hmm.
the hard precision is required,
Hmm.
complicated manufacturing operations are going to be, where
Hmm.
human hazardous operations are there, we can
Hmm.
use the robot.
Okay. Yeah. Yeah. Very nice, sir.
Yes.
So, in automation, hello. So, in automation, the human involvement will be very less, or you can say no human involvement will be there. So similarly in the robotics also, but what is the difference between the robotics and the automation then? The simply automated machine. So you can say the level of automation is much, much greater than the simply automated machine. अगर इसको मैं suppose if I define what is a robot, so a robot is a automated machine, and before that robot is a reprogrammable and a multifunctional automated machine to deal with the object, to handle, to manipulate the object. Okay, so like a CC camera, like a washing machine, like a cooker robot, suppose. So, in this way, due to this difference, we can identify. Hello, hello.
Audience, please mute yourself. If you have any question, then raise your hand. Audience, please mute yourself. And if you have any question, please raise your hand. Then we will unmute you. Then you can ask, or you can also chat box. Ask your question through chat box, but
Yeah,
please mute yourself.
yeah, yeah. So, like a projector we see, like a CCTV camera we see, so there will be nothing kind of manipulation will be done. However, it will be capturing the images, videos automatically, but there will be no involvement of means handling, manipulation kind of things. So in the robotics, there should be some manipulation. Okay, and this I'm going to visualize through the software, and the software name is uh, the Robo Analyzer. You might be knowing. So how to search it? It is Robo Analyzer software. From here, you can get it and see the basic what is a Robo Analyzer. So it is a 3D model based software that can be used to teach and learn the robotics concept, and it is developed by the team of uh, Professor Saha from IIT Delhi. And from where we can get this software? So here, the latest version, you can get the Robot Analyzer V9.1, and now it becomes a commercial. Before I think 2 years, it was not commercial. It was freely available in the website. Uh, but now you can see this V8.1, V9.1, these are now commercial. So you need to purchase from SVR Infotech Pune. Fortunately, I have this software, and which is very useful for the basic learner. So from here, I got software, and the software name is Robo Analyzer. One can see Robo Analyzer. Okay, so before doing this, what is this homogeneous transformation matrices? So from here, you can see transformations. So what is transformation? Like suppose uh, the body has to be transferred from one point to the another, or you can say the robot and effector. Robot and effector means robot का जो hand होता है, the end of the hand which is known as the end effector, और वही end effector है जो which is used for इंटरेक्टिंग द एनवायरमेंट। अगर सीधी से बात करें तो रोबोट का हैंड है वही ऑब्जेक्ट को पकड़ने के लिए, होल्ड करने के लिए काम आता है। ओके, तो उसके लिए सिंपली हम ट्रांसफॉर्मेशन की बात करें। सो व्हाट इज ट्रांसफॉर्मेशन? सो ट्रांसफॉर्मेशन, यू कैन से हियर व्हाट इज ट्रांसफॉर्मेशन। सो ट्रांसफॉर्मेशन इज व्हाट मेकिंग मूवमेंट ऑफ the object from the one point to the another. Okay, and from one point to another, there will be, there may be translation, rotation, or both. So, through this software, we are going to visualize. Now, please look into the window right side and see here local and global transformation. And the local transformation is by default it is clicked, and one can see the translate, one can see the rotate, and in the translate there are three axes x, y, z. Initially the values are 0. After putting some values, then we need to translate, and then we can visualize. Also, if we click the rotate about any axis like x, y, z, then we can see the rotation of the frame. Here, one can see it is the bigger two frames are there, the bigger one and a smaller one. Both are coinciding each other at the origin. So, so this one, the bigger one is the fixed reference axis, you can say, or absolute frame, you can say, and the smaller one, it is the moving frame. Now, so what is the learning here? What is transformation? So definition I have told. And what are the various types of transformations? So pure transformation, pure rotation, and the third one is rotation plus transformation. Sorry, rotation plus translation. Okay. Am I audible? And please let me know if it is useful. अगर लग रहा है कि हाँ हमें कुछ गेन हो रहा है, okay. So now we have to visualize the translation. अभी तक आपने पढ़े हैं या पढ़ाते होंगे translations. Let me know some queries, if there are some queries. No queries, I think. Okay, so now the translation, suppose we want translation in x direction, and some random values I am putting like 4 unit. So along x, now आप देख सकते हैं it is the x axis, and then we can reset. reset करने पे क्या आ जाएगा, ये अपने ओरिजिनल पोजीशन पे आ जाएगा. ओके, and x is equal to suppose again 0, and we want to visualize only z axis translation, and we have put some value like 6 unit. Now see the translation is along the z direction. If we put all the values, means all the axes have some values, then what will be? आप देख सकते हैं, yeah, again after resetting, now we can see okay. So there is a translation, pure translation along X, Y, and Z. So, means what is the meaning of this? What is the significance of this? It is suppose attached to the hand effector, to the hand of the robot. Okay, this frame is attached. And this hand effector, initially it was here at the origin. Now it got translated from here to here. The moving frame, you can say. Okay. Similarly, suppose we want to visualize the rotation. So, rotation, suppose we want z-axis rotation and give some random value, suppose 60 degree. Yeah, आप देख सकते हैं here the rotation is along 60 degree. तो देखिए how many transformation is now? One transformation and again rotation, second transformation, again rotation, third transformation, again rotation, fourth transformation, again rotation, fifth, again six. Okay, after 6 rotations, it comes to the its a position. Okay, and what is the learning here? The rotation is about z-axis. Okay, and which one is z-axis? This one, the blue, marked by blue color, the axis is known as z-axis. And you can see here, this is the moving frame and this is the fixed frame. And both are coinciding. So, suppose there is a rotation about z-axis, so rotation will be there about y and z. Sorry, y and x, not about z-axis. It is very clear. It is rotating about its own axis. That's why. Okay. So, and one thing, very important thing, if you see the matrix, if you see the matrix here, this matrix is known as homogeneous transformation matrix. And what is the significance of this matrix? 4 by 4 matrix. सबसे पहले इसका कैरेक्टर कैसा होता है? 4 by 4 matrix. And transformation, homogeneous transformation matrix means square matrix and size will be 4 by 4. Okay. And from this, what we get information? We get information about the orientation of the and effector. अगर एंगल वाइज देखा जाए तो हमारा एंड इफेक्टर रोबोट कहाँ है, रोबोट कहाँ है मतलब है उसका एंड इफेक्टर कहाँ है. ओके, एंड फ्रॉम दिस फोर्थ कॉलम वी सी द एक्स, वाई एंड जेड पोजिशंस. तो आप देख सकते हैं it is completely there is a rotation. That's why the x value is 0, y value is 0, z value is 0. Okay, so this is a little bit about the transformation matrix. If you want to ask any question regarding this, you're welcome. If you want to interact, okay, what is this transformation and what is this local versus global and what are these things, why we are doing XYZ translation, why we are doing rotation about various axes, and what is this? What is the nature of this homogeneous transformation matrix? And what about the sequence of these transformations? So you're welcome. You can ask questions.
Yes, sir. I think there is no question. Please proceed, sir.
Okay. Am I properly audible now?
Yes, sir. You're yes, sir, properly audible. No problem.
Am I able to make understood?
Yes, sir. Yes, sir. I understand, sir.
Ah, okay, okay,
You
okay.
know, sir, there are the translation matrix, scaling matrix, rotation matrix.
Yeah, yeah,
Uh,
yeah, yeah.
this homogeneous matrix is the concatenation, or you can say integration of all these matrices.
Yeah,
I
yeah, yeah,
think,
yeah.
yes, sir. Am I right, sir?
Yeah. Yeah, yeah, right, right.
Yes.
Integration of matrix means the rotation matrix and the position vector matrix.
Yes, sir.
And this one is a zero matrix and it is a perspective matrix. Means intentionally we make it uh,
Yes, sir.
4 into 4 matrix square so that we can multiply all the matrices and at the last we can get the position and the orientation of the robot. That is the main motto behind the using of this homogeneous transformation matrix. That's why it is written STM module, homogeneous transformation matrix module. Okay.
Okay. Yes, sir. Yes.
Yeah. After this, the
Yes, sir.
second part coming to the software, the main part. Here we will visualize. uh, why this is coming? I don't know. Okay. Let me again. Hello.
Sir, you're audible, sir. Go ahead.
Audible.
No problem.
Audible, na? Okay.
Yes.
Okay. Okay. Now, next is to visualize the kinematics and dynamics of a robot. So इसको पार्ट में समझते हैं. सबसे पहले if you see the DH parameters below, if you see the cursor, there is a DH parameters. Means the 4 parameters, the joint offset, joint angle, link length, and a twist angle. So, and default robots are there with various degrees of freedom. Suppose we select 5 degrees of freedom and anyone like a 5 revolute, prismatic and a revolute. These are the based on the joint types. Okay. So it looks like a robot. And why? What is the use of this robot analyzer software? Suppose we don't have any robot because it is very expensive. And even if you have a robot, so firstly we should know how to handle it. What are the basic things? That's why knowing about this software means having exposure about this. I am not talking about software, the exposure. The motion visualization is very important for the learning point of view, basic learning point of view. Okay. So the robot, you can see here, what is this? This is the base of the robot. And this is what the frame is attached to the base. Okay. And what about the arm? So आप देख सकते हैं, this is the arm where the motors, here the purple color, you can see here, this part is the motor, and this is the part of link. Okay. And what about the and effector? The and effector is attached to the wrist of the manipulator. So this part is and effector. आप देख सकते हैं. And then firstly, how the motion is transferred from the base of the robot, you can see here, to the and effector. And what will be changes? You can see here the DH parameters, there are 5 joints, and the joint types are all are rotary joints. Okay. Not the prismatic. Like in our body, we don't have any prismatic joints. And these 4 parameters just have the means observation after clicking this base frame to and effector. मतलब कहने का मतलब ये है कि मोशन कैसे ट्रांसफर होता है फ्रॉम द बेस टू द एंड इफेक्टर. अब मोशन ट्रांसफर करने के लिए हमें क्या क्या चाहिए रहता है कि कितने रोटेशंस होगा, कितने ट्रांसफॉर्मेशंस होगा, एंड अल्टीमेटली जो मोशंस होगा वो एंड इफेक्टर में ट्रांसफर होता है. ओके. एंड इफेक्टर में ट्रांसफर होता है, दैट इज फॉर द manipulation, that is for the manipulating the object. Okay. So please have a look. Base frame to the and effector. And what is happening, this frame will be moving or translating or rotating, means moving. Okay. आप देख सकते हैं, ये फ्रेम देख सकते हैं, ये फ्रेम यहाँ पे जॉइंट 1 पे गया, उसके बाद देयर इज अ ट्रांसलेशन, देन रोटेशन, then simultaneously just see the below table, that is the homogeneous transformation matrix. No, not sorry, DH parameters. That is the DH parameters. आप देख सकते हैं what is happening, link length. अब यहाँ पे देख सकते हैं twist angle, and now joint number 4 revolute, and a joint offset is this much, joint angle it is variable, then it is taking link length. There is and in this way difficult to follow this, but the good thing is how the frame is got means moved from the base to the and effector. उसके लिए क्या क्या करना पड़ा, तो आप देख सकते हैं क्या क्या करना पड़ा. तो if you see the joint number 1, then which kind of joint is there, revolute, and a joint offset is what, if there is a suppose, let me better, आप देख सकते हैं here the joint offset, this length, and link length, and the twist angle, आप देख सकते हैं joint the data corresponding to joint number 2 it is taking, and the joint number 3 it is taking, and the movement we can see in the robot. What is happening? So it is good for the BTech students. Okay. Okay. Now, it is the 3D model. And the visualization, we can see the motion visualization, we can see through the forward kinematics. The difference between kinematics and the dynamics is what kinematics where we both are about the motions. हम उसमें motions देखते हैं, not the cause of the motion. But in the case of dynamics, we consider both the motion and the cause. आप इसको ऐसे समझ सकते हैं in the case of kinematics. In the case of kinematics, we both are about output, not the input, the force or torque. But in the case of dynamics, we study both कि इनपुट फोर्सेस क्या है, टॉर्क्स क्या है, एंड आउटपुट मोशंस क्या है, लाइक वेलोसिटीज, एक्सेलरेशंस क्या है, पोजीशंस क्या है. ओके, सो through the forward kinematics, now I am going to click the forward kinematics, and the forward kinematics, how one can write the forward kinematics. Suppose you have this robot and you have to write the forward kinematics. So how to write the forward kinematics? With the help of these transformations. How many transformations are there? 5 joints are there. So 5 degrees of freedoms are there. And whatever the number of transformations will be there, the matrices we need to multiply, then we will get the forward kinematics. If we will analyze, okay, so after clicking this forward kinematics, आप देख सकते हैं यहाँ पे analysis is done. अगर इसको हम manually करें, so it takes time. And for the complex robot, it is very difficult. Not easy. Manually we can do, obviously we can do, but it takes time, too much time. Okay, so now our objective is to visualize the motion. So again, once again, this forward kinematics, I have clicked it, and we want to visualize the motion. आप देख सकते हैं. Once again, okay, and it is and this visualization is through the 3D model. This we can see through the graph. Okay, आप देख सकते हैं through the graph. The visualization either can be seen through the 3D model or through the graph. And the graph, you can see here how many links are there. 5 links are there. Okay, and what about joints? So 5 joints are there. एक और joints कहाँ पे? जो link के end में. Okay, and suppose you. Okay, and suppose we want to know where is our robot. Means where is the x, y, z axis of our robot. So x axis, this is the position of the x axis. You can see here. It is the in the x axis, time is there, and the y axis, the position, the linear position of the robot is there. So how x age varies with the time. This variation we can see how it is varying. Okay. What about y and what about z? Okay. Similarly, if we want to know about what are the values, means the angular position of the robots, okay, of joint 5. So this is the angular position, and we want to know the joint velocity. This is the velocity, and joint acceleration. Individually, we can visualize it. Okay, of any links, or you can say any joints, we can visualize. Like suppose we want to visualize joint 1. So this one, this one, this one, and this one. Okay. So here, the difference between the kinematics and the dynamics can be seen here. After clicking this force and torque, suppose we want to know about what are the forces or the torques involved, what are the causes, what are the values of forces and the torques. So we are unable to get this information. Why? Anyone, if you can answer? Once again, after clicking this force oblique torque information, then it is saying the inverse dynamic simulation data doesn't exist. So here there is a difference between kinematics and the dynamics. Okay. So similarly, suppose we do forward kinematics and then inverse dynamics, means the dynamics, then we won't be differentiate between the trajectory motion. The trajectory motion will be same, but through the graph we can know about the forces or torques involved. In this way we can see. So let me have water in between. If you have any query, please you just think about this, and you can ask any questions.
Sir, in definition,
Mhm.
how can we differentiate the forward kinematics and inverse kinematics? Reverse
Okay,
kinematics, I think.
okay.
Yes.
Mhm. Okay. Uh, so this we have done forward kinematics. Now, inverse kinematics, suppose if I click, this is the inverse kinematics. And we can see here, we can select any robot. Like a KUKA robot, if I select, if it is visible properly, this window, new window, I'm moving it. Is it visible?
Yes, sir. Visible, sir. Yes.
Visible. So the difference between the forward kinematics and the inverse kinematics. So in the forward kinematics, what are the things are given? Means input and the output. In terms of input and the output, we can know. I'm talking about forward kinematics. तो अगर आप मुझे सुन रहे होंगे, ध्यान से सुन रहे होंगे, तो जस्ट अपना जो फिंगर है, ठीक है, रिस्ट है, आप जैसे आपके आसपास जो भी है, आपके आसपास जो भी है, जैसे मेरे सामने एक बॉटल है, कैलकुलेटर है, अब इसको मैं सपोज इसको कैप्चर कर रहा हूं या बॉटल को उठा रहा हूं. So for this, what are the inputs? The inputs are joint angles. Joint variables we can say in the case of robot. In our case, joint angles. Okay. क्योंकि in the case of robotics, along with the revolute, the joint may be prismatic. That's why joint variable. So for the given joint variables, what are the values of x, y, z? Or you can say for the given joint angles, where is our robot? So that is forward kinematics. Okay. Now inverse kinematics. अब इसमें क्या हो जाएगा? इनवर्स में क्या हो जाएगा? जो आउटपुट रहेगा वो इनपुट हो जाएगा. In the case of forward kinematics, what was the output? Output was the x, y, z. But in the case of inverse kinematics, it becomes the input. And input x is equal to 0.08 meter, y is equal to 0.1, z is equal to 1.2. Okay. And if I click these inverse kinematics values, means to reach the, आप आपके सामने अगर कुछ चीजें हैं तो आप उसको डिफरेंट तरीके से पकड़ के देखिए. उसको पिक एंड प्लेस कराना है तो कई तरीके हो सकते हैं वहां तक पहुंचने के लिए, आपको हाथ को पहुंचाने के लिए. तो सेम चीज इन द मैथमेटिक्स. See here, this is one set of one kind of solution. This is another solution. This is another third one, fourth one, likewise fifth one, sixth one, 7, 8. Up to 8 solutions we can see by default in this software. Okay. Now, what about, let me ask to show solution 1. Okay. देखिए इसमें इनवर्स कैलोमेटिक्स में x, y, z means and effector position will be fixed. But a configuration, the arm will be having different configurations. Okay. So now suppose the changes, more changes will be there in like solution 5. आप देख सकते हैं and effector age same place, and solution 8, solution 2, solution 4. Okay, so this is the difference between forward kinematics and the inverse kinematics. This we could visualize through this software, and which is really very helpful for the learners. या इसमें और कुछ क्वेश्चन पूछना चाहें तो पूछ सकते हैं. या आप पूछ सकते हैं सर यहाँ पे हम एआई का कैसे यूज करेंगे, आप पूछ सकते हैं. कोई क्वेश्चन आ रहा हो तो आप शेयर कर सकते हैं.
Yes, sir. One question is there.
हाँ.
How to visualize a 2D or 3D robotic arm motion using MATLAB? By Dr. Pandya Viral Kumar.
Okay.
Yes, sir.
Through the MATLAB.
You can check in chat box also, sir, this question.
Okay.
Yes.
हाँ तो मैटलब में कैसे मतलब विजुलाइज करेंगे. मैटलब में थ्रू 2D एंड 3D हाउ टू विजुलाइज.
Yes, sir.
ओके. सो I have used the bond graph model
Yes, sir.
in which that I have exposure. MATLAB I have used for the means very little means a portion for the optimization. So exactly MATLAB, how to use MATLAB for this I cannot say correctly, but
Yes,
that you can have my number. Definitely I will share you the information. I can guide you. But right now, because I have exposure of a bond graph
yes.
software, like in my paper, if you see, yeah, like through this, the graphical way of representation that is known as the bond graph. Through this I have done, but definitely I will share you. You can have my number. I will share you.
Sir, there is one more question.
Hmm.
Hello. From Dr. Himanshu Patel.
Hmm.
How will AI-driven robotics shape manufacturing and autonomous system in the next decade?
Yeah, Miss, it is like a question how AI will help in manufacturing. Is it?
Yes, sir.
Hmm. So, this I can share. Uh, like this is the robot. It has a 6 degrees of freedom, and it is a redundant, means having extra degrees of freedom of the robot. But suppose it is a planar robot, means the manipulation will be done in the x and the y, means or any two axes. Okay, but number of joints are more, means 6, means extra degrees of freedom we have. So in the AI can be used here, like in this case. What are the means the joints the AI can help to get the proper whatever suppose we require the task. So which are the joints can be helpful to minimize the energy consumption. Ultimately, suppose this is for the space robot. The robot is sent to the space where there is a limitation of fuel. So our primary duty is to save the fuel. Okay. So from the design point of view, from the fabrication point of view, which joint should be having means a more flexibility, means all the joints will not participate in the same manner, cannot contribute the same. So that's why, means suppose a joint 1 can be utilized more, joint 5th can be utilized less for the purpose. Suppose a robot is here to robot is employed for the drilling purpose, for the machining purpose, and a robot is flexible, more flexible. For that, the design and fabrication should be what? The robot should be redundant. Why redundant? Suppose there are obstacles in the workspace. So that obstacles can be avoided. Okay. So here we can use the AI for the means exploitation, proper exploitation of the joints so that the obstacles can be avoided. The design can be done accordingly, and then various purpose can be solved, like uh, simultaneously. Suppose we have 6 joints, and suppose at a time 2 joints we want to use, और अदर 4 joints हैं वो क्या इनएक्टिव रहेगा, 2 joints रहेगा वो एक्टिव रहेगा. तो वो joints कौन सा हो सकता है? So how to know that? So that can be known by using AI. So I have used the genetic algorithm in my research. So from that, I was able to save the onboard fuel, so the optimization purpose. So here, for the designing and for the fabrication, obviously we can use the AI in the manufacturing. Is it okay, sir?
Sir, yes, sir. Proceed, sir. Please.
Okay.
Yes.
Okay. And the virtual robot, next stage, the virtual robot. Through this, the learners can have exposure. Suppose you have a robot, and as per your choice, here you can select your robot. Here, selecting and loading, clicking this arrow. Okay. Now, suppose you have to identify the joints, which is suppose joint 1, 2, 3, 4. So, and how to control the joints. So, we can control through the joint or you can control through the Cartesian. ओके लेकिन अगर ज्वाइंट को कंट्रोल करेंगे तो एंड इफेक्टर कहाँ होगा दैट वी कैन नॉट ओके रैंडमली सपोज लाइक आई एम डूइंग हियर आप देख सकते हैं ज्वाइंट एंड इफेक्टर दिस एंड इफेक्टर वी आर नॉट कंट्रोलिंग ज्वाइंट वी आर कंट्रोलिंग ओके बट वेयर इट विल गो दैट इज द क्वेश्चन like a joint fifth joint 6 okay this is through the joint now this can be controlled and why not to record this once again I'm doing it I'm clearing the traces and making it home position and now record start and controlling the joints it is known as jogging and then we can stop it and we can play. In this way, we can control the joints. However, it is the robots initially made for the industrial industry purpose. Industrial robots are made initially. The robot name is Unimate. Through this, however, it is not directly related to manufacturing, but the manufacturing is done through the robots and the basics of robots. We should know what are the basics, how to control the robots, what are the uh, motions, what about the kinematics, what about the dynamics, what about the forward kinematics, what about the inverse kinematics, what about the matrices involved, what about the transformation matrices like a pure rotation and pure translation. So in this way, we can have exposure and that can be, the robot can be used for the manufacturing and that's why we should know the basics about this. And now my PhD students are here to share some electronics parts required for the robot making. Are you ready for the robot making? How to make a robots? Ready? Yeah. And before that, yeah, so please come. And how to ensure whether it is visible or not.
One of the audience is asking that, sir, is this software is open source or paid version?
Initially, it was means earlier it was open. Now it is commercial.
Okay,
Means
sir.
for the one license, 7 lakh something.
Okay, sir.
Now,
So yes, thank you, sir.
my PhD student is here, and he is going to tell about the various parts of the robots. How to शेयर बंद कर देता हूँ, उसके बाद शेयरिंग स्टॉप शेयरिंग ना कहाँ से करना होगा शेयरिंग कैमरा चाहिए ना हमें मैं कहाँ पर हूँ अच्छा ये ना यहाँ
Sir, I think stop presenting so that it will
हाँ
be seen in the bigger screen. The video will
ओके
be seen in the bigger screen.
ठीक है
Yes. I am Manoranjan Kumar. I am doing PhD under Dr. Vijay Kumar Dalla, sir, in
Yes.
the field of underwater robotics.
ऑडिबल सर
Yes, sir. Audible, sir.
The speaker is more.
More
ऑडिबल ना
please speak in some more volume, sir.
okay.
Audible, no problem. Ranjan, sir, please speak in more volume. High volume.
Yeah, Dr. Tonde, audible na
Yes, sir. Yes, sir. Yes, sir.
okay.
Okay. So here we have some components related to robotics. As we know that we can use basic part are motors for movement. For power we use batteries, and for sensing we use sensors, etc. So here we have one component. This can be in this one. Okay, this one is a linear actuator. Basic operation is video is not visible.
Hello.
Yes, sir. Visible, sir. Visible, sir. No issues.
Video is visible na
Yes, sir.
okay.
Continue, sir. Please continue.
Yeah this one continue.
Okay, so this is linear actuator in which we are going to power input in the form of voltage, constant voltage through LiPo battery or any power sources. Here we have LiPo battery, lithium polymer battery. It is basically based on different types of cells here. As you can see here, this is 4S battery. That means one cell is 3.7 volt and totally it is 14.8 volt. And using this, we are going to operate this linear actuator. And if I connect this linear actuator through this LiPo battery, you can see the motion of the tip of this linear actuator. Here you can see that length is going to increase slowly. Its speed is 7 mm per second of increase of length, increasing of this length. Similarly, if I reverse the polarity of the input of linear actuator, what will happen? It will motion direction of motion will be reversed. That means it is going backward. Okay, it can be clearly visible. Length of this rod is going to decrease.
Yes, sir. Yes.
So this is a linear actuator in which basically one single motor is fitted, and with the use of gears, this linear rod is going forward and backward. So apart from these, basically every robot has a microprocessor or microcontroller for programming purpose. Here we have one of them. This is a microprocessor. This is actually a Raspberry Pi, which is also known as mini computer, in which microprocessor is inbuilt, memory card, RAM, everything, and we can do every connection with the help of this, and we can control everything and process everything. Suppose we want to add some camera sensor, some IR sensor, and some for obstacle detection like ultrasonic sensor. Everything we can connect and control from this microprocessor. Okay. So we have various types of motors for the operation of robot. Here, one of them, that is, it is a stepper motor. A stepper motor basically does not rotate directly. It basically rotate in the division of degrees. That means one complete rotation is 360 degree, but it rotates in steps. That means 0.8 degree in one step or 1.8 degree in one step. That will depend upon the motor's specification. So when in one step it is set, it is programmed, it will go 0.8 degree or 0.1 degree. And for complete rotation, it will have to go through different number of steps. We can find by dividing 360 by 0.8. Okay. So this stepper motor basically uses power more than the DC motor, because it has a two-phase motor or three-phase motor, in which basically it when it is powered, it locks its spindle so that it can provide a stop or that much power, so that it will maintain its position at anywhere like 180 degree or 20 degree, everywhere it can maintain its position. So here we have one more motor. This is basically a DC motor, direct current motor. We can operate this by giving the input directly from these two wires, red and black. But you can see in the back of this motor some black thing it can be visible. This is encoder of this motor. Now this encoder is new thing which basically used for DC motor to locate its position of the motor. Every time what is the position, so suppose it will 120 degree, 150 degree, everywhere it will locates its position by emitting light from the encoder, which will read every time continuously, and it can be programmed through here one port is also where you can connect this from any microcontroller or microprocessor to program or control this motor. Apart from this, we have servo motor, which is basically used for the joints of humanoid robots or different type of robot to operate. Basically, servo motor does not rotate in complete rotation, that is 360. It can rotate in a range of angle, and that may be 160 degree, 180 degree, or 270 degree, etc. Here we have joined two motors perpendicularly. You can see it is a small SG90 servo motor, basically generally used in the robotics. Here we have different types of sensors. This you can view. This is IR sensor, infrared sensor, in which two LED lights are used, one black and one white LED light. This basically emits infrared light, and when it emits and reflected back from any surface, it will observe that how much distance any object is from this sensor, and in this way we can program different things in the robot. Similarly, we have one more. This is Bluetooth module. Can you continue? Yes, sir. We have shown one microprocessor, that is Raspberry Pi. We have different types of microcontroller, which is basically the Arduino. And Arduino has different types, like this is Arduino Mega, which uses different type of microcontroller, which is 2650, I think. 2560 microcontroller, and this is Arduino UNO. I think you have already gone through this. So these are microcontrollers, and Raspberry Pi is a microprocessor. Difference between these two are these can only be programmed, and it cannot process any data or anything that we are going to input this device, this microcontroller. But in the place of that one microprocessor, I can visualize images or process images or any code it can process. So
In this way, we try to give exposure regarding the basic components required to make a robot for the various purpose. And at the last, I'm going to share the activities involved in our robotics and embodied AI laboratory at NIT Jamshedpur, developed by me. This one can see, this is the robot head. It can interact with the audience, developed by the BTech students. Like if it audible, and the lab developed this is the robot. 6 degree of freedom robot. 2 projects, underwater projects are running. So, and other than that, some BTech students, the projects. In this way, from our side, we tried to uh, give exposure the basics of robotics and the basic components required for the robotics. And the robotics can be robots are being used in the industries very much now. Now it's uh, nowadays robots are being used in industries too much for the automation purpose. So I think this exposure may be little bit helpful for the participants. So from my side, as I was given time from 11 to 12:30, so we have done this. If you want to interact with us, with me, you're welcome.
Dear participants, if you have any question, please ask. If you have any query, please, you are free to ask, and sir will definitely answer the questions. And all the participants are requested to please ask the questions if you have any questions regarding this session. Okay, so I think there is no more questions from the audience side. So this is the time for the vote of thanks. So I would like to thank the most eminent resource person, Dr. Vijay Kumar Dalla sir from the National Institute of Technology Jamshedpur. So sir has given a very informative, very interactive session. Sir has given his presentation and exposure, live exposure, hands-on exposure on the software. Robo analyzer software is there, and sir has explained different kinds of robot dynamics and kinetics, and the different types of kinematics of the robots, different forward kinematics and inverse kinematics sir has explained. Sir has also explained about the different types of joints in the robot and the control systems, how the robot moves from the robots in effector basically moves from the one location to another location. And special thanks to his PhD scholar, Mr. Ranjan Kumar sir, who has given and shown the different projects and different components of the robots, and like actuator, AC motor, DC motor, then microprocessor, microcontroller, servo motor have been shown. So I think this was a very good exposure for all the participants, and they have got learning through this session. However, on behalf of Sriyash College of Engineering and Technology, Chhatrapati Sambhajinagar, and on behalf of AICTE Atal Academy, I would like to thank Dr. V. K. Dalla sir and his team, and I would like to extend a sincere gratitude to all the resource persons of this AICT faculty development program on AI-driven advances in mechanical engineering, and definitely the robotics is one of the part of mechanical and automation engineering. So your valuable sessions, expert insight, and real-world experience have truly enriched the participants' understanding and inspired them to explore AI applications in the field of robotics, robot with motion visualization especially. And we deeply appreciate the time, effort, and commitment you devoted to making this FDP a great success. Your contribution has added immense value to this academic endeavor. Thank you once again for your support and for being a part of this program. I would like to thank our Chairman, Engineer Basavaraj Mangrule sir. I would like to thank our Chief Executive Officer, Colonel Joy Daniel sir. I would like to thank our respected Principal, Dr. B.M. Patil sir, our Dean Academics, and the uh, coordinator of this FDP, Dr. P.M. Ardhapurkar sir. I would like to thank all the team members of this FDP, the members of the faculty members of the Mechanical Engineering Department of Sriyash College. I would like to, at last, I would like to thank all the participants who have joined this session and trusted us uh, and joined this FDP and enrolled through the AICT Atal Academy. And I would like to thank the AICT and authorities of the Atal Academy who have approved our proposal. And I would like to thank the Ministry of Education and Government of India. Thank you everyone. The next session will be start at the 1:30. Please be ready. And at the chat box, we have shared the feedback form. Please share the feedback form. It is essential for your certification. So thank you, sir. Thank you, Dalla sir. You have I'm highly obliged. You have also always supported us. Thank you for your guidance and time.
Thank you. Na? I'm leaving. Na?
Yes, sir. Audience, you can leave. We will meet at 1:30. Thank you.